Hi guys, we meet again in the same topic of chapter 2, which is atomic structure. As I said before, atomic structure has three subtopics: Bohr's atomic model as 2.1, 2.2 is quantum mechanical model, and 2.3 is electronic configuration. I still will explain the same topic, which is Bohr's atomic model, but this video will explain more about spectrum. Before I go through to the types of spectrum, you should to understand what is meant by spectrum. Spectrum is a range of electromagnetic radiation with respect to its wavelength and frequency. There are two types of spectrum, which is the first one are continuous spectrum. The illustration shows to you the type of continuous or the example of continuous spectrum. The second type of spectrum are line spectrum. So this is the illustration or the example about the line spectrum. There are two line spectrum, which is absorption spectrum and emission spectrum. Guys, you will be more understand when you watch this video. This animation is about continuous spectrum. This spectrum is due to dispersion of white light. Dispersion of white light gives vibrant colors on photographic plate without any gap between each colors. This type of spreading colors is called continuous spectrum. White light produced from sunlight. Incandescence, filament lamp, and solid or liquid at high temperature give incandescence. Vibrant means violet, indigo, blue, green, yellow, orange, and red. Guys, it's time to you to understand about absorption line spectrum and emission line spectrum and the difference between both of the line spectrum. Watch this video.
In this video, we're going to look at absorption and emission line spectra. So we'll start with a quick review of the Bohr model of the atom. The protons and neutrons are located in the nucleus of the atom, and the electrons are located in energy levels or shells around the nucleus. Electrons can only exist at certain energy levels with discrete amounts of energy. So an electron can occupy energy level 1 or energy level 2, but not in between energy level 1 and 2. The next point is that electrons can transition between energy levels. So that means an electron can transition from n equals 1 to n equals 2, or from n equals 3 down to n equals 1. If an electron absorbs a discrete amount of energy, it can transition to a higher energy level, which is called its excited state. So for example, an electron can absorb a discrete or exact amount of energy, and it will transition from an n equals 1 to an n equals 2 energy level. If an electron emits a discrete amount of energy, it can transition to a lower energy level. So for example, an electron in the n equals 2 energy level can emit or give off energy and transition to an n equals 1 energy level. So next we look at how these electron transitions between energy levels give rise to absorption and emission line spectra. So here we have again the Bohr model of the atom, and here we have an electron in the n equals 2 energy level. And these arrows show the electron transitioning to the n equals 3 energy level, the n equals 4 energy level, the n equals 5 energy level, and the n equals 6 energy level. And here we have an absorption spectrum. You may remember this from the previous video. An absorption spectrum has black lines on a colored background. Below our absorption spectrum, we have the energy levels of the atom from n equals 1 to n equals 6. And as you can see, the colored arrows on the diagram, they correspond to the colors that are missing from the absorption spectrum. As we mentioned earlier, electrons can transition between energy levels if they absorb discrete amounts of energy. So if we start with this red arrow here, the electron has transitioned from the n equals 2 to the n equals 3 energy level, and the energy that the electron has absorbed corresponds to the wavelength of red light. Next, we'll have a look at this blue arrow here. The electron has transitioned from the n equals 2 to the n equals 5 energy level, and the energy that the electron has absorbed corresponds to the wavelength of blue light. So to summarize, the reason for these black lines on an absorption spectrum is that the electron transitions between n equals 2 to 3, or 2 to 4, or 2 to 5, or 2 to 6. The electrons have absorbed the energy, and the energy that's absorbed corresponds to the wavelength of visible light. So in the previous example, we saw how electrons can transition to higher energy levels when they absorb energy, and the energy that they absorb is related to the wavelength of visible light. One thing you'll notice about this diagram is that the arrows are going in the opposite direction. So these electrons are transitioning from higher energy levels to lower energy levels. And again, each electron transition has its own color. So here we have our emission spectrum, which has colored lines on a black background. So here we have the energy levels within our atom from n equals 1 to n equals 6. So we'll start with this red arrow here. This red arrow represents an electron transition from the n equals 3 to the n equals 2 energy level. When an electron transitions from a higher to a lower energy level, it emits a discrete amount of energy, and the energy that is emitted by the electron corresponds to the wavelength of red light. Next, we'll have a look at this blue arrow here. This blue arrow represents an electron transition from the n equals 5 to the n equals 2 energy level. And when the electron transitions to a lower energy level, it emits energy. And the energy that's emitted by the electron corresponds to the wavelength of blue light. So to summarize, the reason for these colored lines on the black background of an emission spectrum, they correspond to the energy emitted when an electron transitions from a higher energy level to a lower energy level, and in this case the energy level is n equals 2.
Because you're going to learn about the emission series of hydrogen spectrum, guys, let's watch this video.
Spectral lines of hydrogen atom. According to Bohr's third postulate, when an atom makes a transition from the higher energy state to a lower energy state, the energy is radiated in the form of a photon having certain frequency. The spectral lines arising from the transition of electrons of an atom from higher energy states to a definite energy state form a spectral series. The various spectral series of hydrogen atom can be represented with the help of orbital diagram of an atom, as shown in the animation. When a transition from higher orbits to the first orbit occurs in the atom, Lyman series is obtained. The values of frequencies obtained in this transition lie in the ultraviolet region of the electromagnetic spectrum. When a transition from higher orbits to the second orbit occurs in the atom, Bohr series is obtained. The values of frequencies obtained in this transition lie in the ultraviolet region of the electromagnetic spectrum. When a transition from higher orbits to the third orbit occurs in the atom, Paschen series is obtained. The values of frequencies obtained in this transition lie in the infrared region of the electromagnetic spectrum. When a transition from higher orbits to the fourth orbit occurs in the atom, bracket series is obtained. When a transition from higher orbits to the fifth orbit occurs in the atom, Pfund series is obtained. The energy of emitted radiation is given by the formula shown here, and the Rydberg formula for the spectrum of hydrogen atom is given by the formula.
Guys, I hope you got the very good information about spectrum after watch this video. Thank you for watching. Bye.